Welcome to a new Teardown video. This time it's another HP. Distortion Analyzer Model 300C. Well, look at that. The font they choose for the C is just so bad. It's almost impossible to see. It's a C. It looks so much like 3300. I'm saying sorry about that. That is a little bit. Anyway, this is a nice distortion analyzer and a very impressive RMS voltmeter as well, covering from 30 millivolts all the way to 300 volts. So you also get a really good RMS voltmeter at the same time. And I guess this is how you use this this feature. So you can go into meter, and then you have your voltmeter, or you can go to set level, and this is of course where you calibrate. You set this right, of course, and then you calibrate the input signal. So AF or RF. This is because this unit also got a connector on the back, and on the back side it's called RF. As far as I can see, the only difference in this model is a decoupling capacitor, actually, but it's supposed to be some other filters and stuff, and that is actually what this hole is for. So that will be the RF pot meter. So this one will only use the AF input, and that is this one. And so that is what we will do. This is the frequency ranges. It is a little bit misplaced here, all the way over here. So, well, this will be the frequency ranges, and it covers from 20 Hertz to 20 kilohertz. As far as I've been able to see, there's a little bit of a weak, the weak coupling, so it's not always following when I'm dialing around here, see? So then I need to take this one, and then it works. So I need to look at the mechanical interface here. There's probably something that needs to be fixed. We got a nice meter output, so that is great. We can put a DC voltmeter or something on here. We got the oscilloscope output that is, of course, before it's rectified for meter driving. So and the balance that is used for distortion. And this one can also read out the noise instead of distortion. So that is a little bit interesting too. I look forward to power this up and see if it works. It is, I think this is from 1948, 1950s. This one can be a little bit younger because it's looking really, really nice. I think they produced them in like 15 years span at least. So we're gonna power this up. So before we power this up, we need to investigate a little bit on the rear. So this is of course the hum balance, and this is what I said, the RF input. And we are not going to use serial number and stuff. We can't see anything about its year of manufacture or anything. There's a little bit of a shame. Look what I took off out of the main skeleton. Some dead bug. I think this is a spider or something. And one of the fuses is missing, and the other one is 1.5 amp, and that one is correct. And this looks a little bit like a modification. Look at the 4 screws like that. So this is a nice modification for the preferred Euro connectors. Yeah, we like those. And of course, because I always save those fuse sockets when I trash something, and it's like rarely trash something, or it's broken or beyond economical repair or whatever happens. Yeah, I save these from all the different types of equipment, as well as other good and useful spare parts. And look what we got. See, that is just the most easy way to repair this. And then we're done. Yabba dabba doo, and it's restored. Ha ha. So, I think we're ready. I got 1 volts RMS of 1 kilohertz ready to plug in. I got the scope connected, and I got 220 volts. I think we should just plug this baby in. And flippity flippity. Hundreds of watts. Oh, that's a lot of watts. But it's dropping a little bit, so that is a good sign. And there is beautiful light in there. Wow, that looks nice. I also saw a little bit of reaction there. I thought it should be ready now. It is in meter. 1 volt full range. So let's plug in the... Oh, okay. Oh, I'm an idiot. I forgot to turn on the generator. Yeah, but I don't see anything. Hello? Set level. Okay, so set level works. So this meter thing, I don't know what that is. Obviously doesn't work. But set level is... Oh, look at that. And hello. Okay, it's alive. So if this is a level, I need to put it up to full scale, right? And then I hit 100% and distortion. And then I dial the frequency. Oh, look at that. I got exactly the response I was looking for. So that is 100%, 30%. Or is that? No, I'm a jerk. It's the other way around, right? So if this is 100%, yeah, it goes this way. 10%, 3%, 1%. Okay. Okay, this is a little bit of full. Oh yeah, look at that. So this is the 1%. And then we try the balance button. Ooh, okay, this needs a little bit of exercise. Ha ha. It is actually working, and it's, if I show you guys this the scope and the dial at the same time, see, then I got a signal and then it goes away. So it's all about finding the spot where it's completely gone. So this is 1%. I think this is as far as this meter can go, right? There is no... As far as I can see here, the meter only go to 1%. So this is 1% full scale, and then I have 0.0 something nothing. So yeah, and it's still not super crazy and super sensitive. I got 1 kilohertz of input, and the readout is a little bit off, but I think it's quite close. When you think about this, I think it's from the 50s, right? So it's quite old, but it really works. But why? Okay, so that was the distortion, that was the set level, this was noise. Ah, yeah, okay. And then I got a lot of, so in the noise output, what is it doing? Then I get everything as a signal, obviously. I don't understand that. So that is how it is in noise, right? And then that is the set level, distortion, meter. Hello. Maybe I should just try and read the manual or something, but nothing in meter. What am I doing? Okay, now it is. only get something on the meter when I poke around with a why is it so annoying? Okay, so the meter is again just showing the same as distortion. I don't get it. See? Meter. Whatever. This is probably carefully explained in the manual. But I think we should try and open this baby and see what is inside. Don't you just love it? This is so beautiful. So I took off the top plate. Everything is just so nice. We got them really old metal cased tubes here. They are really, really nice and old. So that is before 1950s. We even got notes on them because they've been tested. There's a lot of dust and stuff here, so I'm gonna go and give this some high pressure air, and we're gonna get it nice and clean. So because this works from 20 Hertz to 20 kilohertz, the capacitor is just huge. But still, imagine the impedance this must run at, because it's at 20 Hertz. That's quite... you need quite a lot of capacity, I guess. And here is a capacitor that goes through this ceramic feed through. And the text and stuff here on calibration points. I also like the wire that goes here. And this is the coupling that is not working so well anymore. Ooh, oh, yow, that was a very hot tube I just touched. That is not such a good idea. So if I take... No, it's a small wheel down here. Okay, so it's done. Yeah, okay, this is the classical way that HP are doing this. So it's on the edge of the big wheel where the small wheel is connecting. So that means we need to go in here and have a look before we can fix that. There's also this plate here that is a little bit in the way, and it looks like it can be easily removed by just, yeah, those two screws. And then we should slide this out so we can see what the heck we're doing, and then we can probably see them a little bit more. And this is the bulb. We also got some wires and stuff. I don't know exactly what that is good for. Plate is not an original either, so I guess this unit was in one of these sexy HP cases or a 19-inch racked mounted, but it was modified with some self-made aluminium plates. And don't you guys just love it when people make stuff the right way, of really, really high quality aluminium plates and accurate to the measurements and everything? So it's really nice and a good modification. So here we go. This is the bottom stuff, and it is so beautifully made. Everything is lined up neatly. You can get your hands in everywhere, and it's not made as compact as possible, but doesn't need to be small and compact and annoying to work around with. See? All the resistors and parts up. This is super nice style. The good old tech. And look at the front. This is a die-casted aluminium piece that is as big and stable as you can make it. And this is the coupling that I need to see how I can fix. There's probably something here where I can adjust the degree of coupling because it's lacking grip. So that is something. How do I fix that? Ooh, what is that? Some diodes fix mod. That is a little bit interesting. And this paper cap looks a little bit crusty. But I'm gonna go through everything much more. Throughout everything and looking for weak or odd components. This one has also been modified. This is not an original. So there are some internal pots, and this is also a little bit funny mod. I am a little bit worried about this resistor here and the other. So this is the input attenuator. You see this splatter of stuff on the aluminium shield? Where is that coming from? Is that the switches splattering it? Can I? Yes, I could. So there's some splat. Oh, okay. It is that. See? The ball. Somebody added a little bit of a glue, and when this ball was doing this, it's very aggressive, the jump. Dunk, 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 splats of. Let's see if I can get a little bit of light down here so it's splattering all over the place. So this is what happens. Look at the front plate. So it's a solid 5mm aluminium plate. So there's no flimsy jimsy here. No. This is some serious stuff. You can drive a car over this one. Absolutely far from what you can do with a heat kit. Yeah, that was the mains input. So there was originally a round connector. So this has been modified for this type of connector. That's great. So this 1.5 amp fuse, that was the mains fuse, and it didn't say anything about that on the outside, so that's a little bit annoying. It could have been great to at least say what it is it's protecting. Okay, so mains goes here, and this is the on-off cable. There will be a way to... Yes, there was. Look at that one. This is the jumper to make it 220. So here is this gripper or wheel that is not having enough tension. So here there's a spring that actually pushes these two together, and the spring is mounted underneath the knob that is right here. So I think if I release the knob and move the knob a little bit closer, and maybe also release this one and move this one that way, then I can get more tension on the spring, and this way better contact. I also think that if I put in a cotton bud like this and clean this up, see, the more clean those two surfaces are, the better grip I will get. Yes, that was absolutely correct. The spring was under here, and it was hitting the back side of the knob, standing it like this. So I tried to pull the spring a little bit apart to make it a little bit more stronger, I guess. It's a little bit soft, and has also something to do with where you put the knob. So I'll try and put the knob as close as I can without hitting the front plate. So this is the scale glass with a little line in it, and this is where the light bulb goes through this hole, and it is held in place by the two screws. It's also holding the top aluminium plate here, and it was a little bit difficult to access here, and you can't pull this out because of this screws in the way. And when you loosen this screw, you can pull back the light bulb holder. So I will clean this up as well a little bit. So this is how the mechanics works of the scale. It is connected via all those strings, and this is how they transfer the movement or the rotation from one axis to another one. And it seems like the stop of the capacitors actually matches perfectly with the lines of the scale. But maybe I can move this a little bit and get it to read out exactly 1 kilohertz. Or maybe you're not supposed to do that. I don't know how you change the alignment here, because it seems like there's no fixed point. Oh yes, look. Here the wire is fixed to this one, and then it goes. Maybe it's fixed. Yes, it is also fixed down here. So that means the only way to adjust for this is to loosen one of the screws here and then move. To move this, I guess you could call it a pulley or something, right? And then you can move the scale. Maybe there's. What is the idea with this spring here? Now I figured this out, what this spring is doing. So the spring is the return path of the wire. So if you see on the left side, the wire is mounted here, and it goes around, comes up and goes around the capacitor side, and then it comes back here. And of course this is just the return path, and that is handled by a spring. So is this wheel here is actually not connected to that one, but it's connected via this spring to the shaft. So that is how it works, and this keeps the wire tight. And of course it is also pulling the capacitor in one direction, in this direction, and not in that direction. So that is how it works, and there's no slip-slap in it or anything. So that is fantastic. And of course, if you need to move the dial, you can just loosen the capacitor side here and just move it here, or you can of course loosen this wheel and move that one, because they're connected like this, right? So down here there's a string, there's a screw. You can loosen. So now comes the fun thing. Can we figure out what is the idea with those two springs? See, that looks a little bit funny. I'm not sure I can figure that out. It looks like it's just to make sure the screws don't fall on the floor when you untighten those. I don't know. Well, it looks weird. Let's see, we also got screws down here, and then we can adjust for the frequency. But probably there will be another way to do this electrically. It's probably just this capacitor down there. But I think we're not going to touch anything at all. We need to read very carefully the entire service and adjustment manual before we screw around with stuff, and this is also what I would recommend anybody else to do. Read carefully all the instructions. Don't try and think you can just adjust something easy. There's always a big and deeper science to everything. in instruments like this.